Today, we are gonna do some talk about the IA for some parts here. So item number one, we're going to assign you to write your introduction section for your IA. So this assignment details are in the IA Stuff tab on the OneNote. It's titled Part 3. So the descriptions about how to turn it in and what it's going to be graded on are there. If you want to look more about what should, if you look at Part 3, like you look at the introduction, this is what, this is the kind of stuff it should include. Okay. Let's plan on that maybe by today's Friday, let's say Tuesday. Okay. Should be, just the introduction. So probably 1 to 2 pages is typical length. You have to do the cover sheets and stuff, but not a big deal there. All right, any questions about that? On where to get the details and what to do? Okay. All right. The rest of what we're going to do today is we're going to talk about processing our data. I'm just going to open this other thing up for me. So if you have all of your data collected, you can follow along with what we're doing. If you don't have data collected yet, that's fine. But make sure you make note of this video, because you'll probably want to go and pull it back up to kind of follow along when it's time to, once you've finalize your data collection, to process things. As long as we're talking about data stuff, Emerson, your survey is broken. So nobody's been able to access it, I found out today. So you need to take a look at that and send me a new link and I'll update that. It is what it is, dude. Jamie. Sure. All right. Now, everybody else, lock in, because we're going to learn how to use Excel today.
Yes.
Yes, it's really fun. Potentially, this will be one of the most valuable lessons you get for any future thing you might have to do, because everybody uses Excel. It's not hard to use, but if you know how to use it, boy, that's a time saver. All right.
Should we open Excel?
No. It's up to you, man. If you have your own data, if your data is done and finished and collected, you can do this with your data and follow along. What's up? Well, I have in my sample about 50 data points. Unless you have that many responses for your survey, probably not enough.
I have 52.
Okay. Yes, Colby.
I haven't gotten any responses. Or if I did, I don't know where to find it. Where do I even go to look?
So if here, if I'm looking at this person's up at the top where it says responses, I can click and I can look at this stuff, and I can even, you know, like download the files as like an Excel file or whatever. You can download a CSV and then open that with Excel and then resave it as an Excel file. But like that's what you're doing.
I thought I was gonna get emails or something.
No, you'll get no notification.
Okay, thanks. That's really helpful.
Okay. All right. So Nicole, you can try, and we'll see if you have enough data to get to pass the large counts condition. And if you do, you can be done collecting. And if you don't, then you'll need some more. All right. So before I begin processing this made-up data that we're looking at, I'm going to do a little extra piece that if you're doing surveys, you wouldn't do. But if you collected data from an external source, you would. So if you are an external data selector, you'd want to pay attention to this next step. Okie doke. All right. So what I would do is I'd start by making a new column next to my XY data. In the box immediately next, the first box, I'm going to type in like the number 1. And then in the next box, I'm going to type the equals. I'm going to click on the cell above it, and then type in +1. And then I'm going to click that cell that I just made, grab the corner, see how my cursor changes from white cross to black cross. Once it's the black cross, I'm going to press the left mouse button and drag down so that all my data has now been assigned a number. Once I've done that, I'm going to pull up my graphing calculator. I'm going to press the math button and go over to PRB, and I'm going to select the command random integer no repeat. I'm going to go, I think for you guys, this should bring up a table or a menu in your calculator, but I'm going to go from 1 to 50. So those are the integers I'm using, 1 to 50. And then I'm going to select, say, 25 of them. Now, if you collected data from an external source, how many should you pick? As close to 10% as you can without going over 10%. Why 10%? That's the randomness condition for the chi-squared test, is you can select no more than 10% of your population. Okay? Realistically, it needs to be at least, you know, like in that 50 to 70 data point range. More is safer. So if you don't have that, if you only have like 100 things collected, you're going to need to get some more. Okay? If you're a survey person, we're going to assume that the survey is random because the people are responding or not. Henry? No, not too much. There's no such thing as too much. Emerson? Okay, send me an email and I'll update your link. So I pressed shh. So I went ahead and did this random draw. So I now have 25 random numbers between 1 and 50. I'm going to store that list into L1 so that now I can do list, second list, ops, and then sort ascending on list 1. So when I look at list 1, now my values are in numeric order. So I can go to my list now and like highlight my ones that I randomly selected, because that's the stuff I'm going to use to make my data to do my sample. What's up, Quinn? Okay. This is what I did. Math, probability.
Wait, is this to make a chart for our IA?
No. No, what is this for? If you collected your data from an external source, i.e. not a survey, you need to make a random sampling from your population. This is how you randomly select your data points. If you did a survey, do you have to do this? No.
Not at all.
Okay. Everybody get the idea? What I would do then is I would like copy my list onto a new sheet and delete out everything other than the random selection, but I want to retain the original data so that I can save that for posterity in case I make an oopsie and need to recover it. All right. Next up, we have our data set then, right? If you collected your own data, you've done your random selection, weeded out everything else. If you did a survey, we're at the same spot. The first thing I need to do is I need to decide on some boundaries, some categories for my X and Y variable. So this made up IA data set that I have here is for height and shoe size. So the first thing I'm going to do is I'm going to sort my data by the X variable from biggest to smallest or smallest to biggest. So I'm going to highlight both sets of data. See how both of them are highlighted. I'm going to click the Data tab. And I'm going to pick the Sort command or the Sort button. I'm going to sort by heights. And I'm going to sort smallest to largest. It is critically important when you do this that you highlight both columns because I need the X's and Y's to stay paired. If you don't highlight both columns, it's just going to sort one column and leave the other column alone, and now you've ruined your data. Okay? You'd have to go back and start, re-download your data or whatever and start fresh. Or undo it, until you got back to before you, unpaired your data. All right, so I'm going to hit OK. Everybody's OK? Now, goal is that I want to try to make a 3x3 table. I will settle for a 3x2. I do not want a 2x2 because it means there's extra hassle that I have to go through, like including correction factors that we just don't want to have to do. It's easier to just collect more data. Everybody's okay? So what I'm going to do is I'm going to look at my values here in the height column. And I'm going to say, okay, I go from 61 to 76. So maybe I'm going to go like every 4, and that'll be a grouping. So for right now, I'm going to just highlight those. So 61 to 65. And then I'll go like 66 to 70. And I'll highlight that a different color. Oops. One more. And then I'll go 71 to 76. And I'll highlight those a third color. Everybody's okay? So in my observed counts, I'm going to write 61 less than X less than 66. And then I'll go 65 less than X less than 71. And then I'll go 70 less than X less than, I'll just do like X is greater than 70. And to help me remember that, I'm going to color code these to match my cells as to make the counting easier when we get there. Is everybody okay with what I've done so far? Okay. I'm now going to re-highlight both columns. And now I'm going to sort my data by the y variable. So my y data goes from 7 to 15. So maybe I go by 3 shoe sizes. You know, there's about 8 units there. So 3 shoe sizes is going to go 7 to 10. And I'm going to give that a color, a new color. Maybe I'll do orange. And then we'll go 11 to 4. Oh, I did too many. I shouldn't have taken the 10s there, huh? Okay. We'll do 10 to 13. And I see already that's going to not work for me, right? Maybe I go 10 to 11. Give me a color that it doesn't look like any of the other ones. I did that already. Oh, purple. I love purple. Cancel. Okay. And then we'll do 12 to 15 as my final one. We'll do red there. All right. So I do 7 less than x less than 10. We'll do 9 less than x less than 12. And we'll do 11 less than x. And again, I'm going to match these up color-wise so that I remember what goes where. Oops. Gosh dang it. I put those in the wrong spots. Yes. Okay. Is everybody okay with what I've done so far? The only reason I'm color coding this is to make it easy to do my counts now. So my observed counts, I'm going to start with yellow and orange. If I look, that's all of my yellow and orange. That's going to be this box. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 that are going to go there. Everybody okay now? Now I'm going to do green and orange. That's all of them. So I have 1, 2, 3, 4, 5, 6, 7. And then I'm going to do orange and blue, which are 0. Next, I'm going to do purple and yellow. I have 2 of those. Then we'll do purple and green. So I have 1, 2, 3, 4, 5, 6, 7, 8. Then I have blue and purple. So I have 1, 2, 3, 4, 5, 6. And then I have red and yellow. I got just 1 of those. Then I have red and green. So there's 4 of those. And then I have red and blue, where there's a bunch of those. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Gosh dang it. All right. Everybody okay so far with what I did? Now I'm going to compute the totals. I am not going to do this by hand because if I end up having to go back and rearrange something, I don't want to have to add them up again. Okay? Because I don't know if this arrangement that I've done is going to work. So I'm going to do, in this first total box, I'm going to click up on the command line. I'm going to type the equal sign, and then I'm going to start typing the word average. Excel is going to start trying to autofill the formula. I want just regular old average, so I'm going to double click on that. And it says to just highlight the stuff that I want to average. I just want the average of those three. That's not what I want to do, guys. I'm so sorry. I don't want average. What am I supposed to be doing? Sum. Sum is what I want to be doing. I'm just supposed to be adding these things up. Great googly moogly, Mr. Kulik. So we have 17 in the first row. Now look, I'm going to go to the cell. I'm going to highlight or wait till go to the bottom corner where my cursor turns black. I'm just going to drag down 3. I did not have to do it again. Ooh. I'm going to go over here and I'm going to do equals sum parenthesis, and then I'm going to highlight this set of data. Press enter. And then drag. And notice how many total do I have? 50. How many data points did I have? 50. That means I counted them all, right? Everybody see why, again, letting the computer do the count for me is super helpful. And let's say we go back and we move something around and this one ends up being 3 and this one ends up being 0 later. Everything updates automatically, right? I don't ever have to calculate the sums again. Everybody good? All right, let's do the expected count calculation now. So I'm just going to highlight in my labels that I filled in from above. Everybody's good? So I just copied and pasted them in. To do the expected count, I have a formula. What's the formula for expected counts for chi-squared? Nope. It's row total times column total divided by overall total. So in here, I'm going to start by typing equal sign. So row total, and then I'm going to type shift and the number 8 to get the time symbol. And then column total, I'm going to type the backslash for division. That's right next to the shift button. Divided by overall total. And I'm going to press enter. Uh-oh, what do you notice? Didn't pass the large counts condition, right? Okay, well that's a problem, so we'll have to address that in a moment. I'm going to finish calculating the rest of my expected counts though, so I can see exactly which ones have extra in them that could be lessened and which ones have to get more observed counts in to bolster. Everybody okay? So I'm just going to continue doing this. So row total times column total divided by overall total. Little worse yet. Row total times column total divided by overall total. Still doesn't pass. Row total times column total divided by overall total. That one's good. Row total times column total divided by overall total. That one passes. Row total times column total divided by overall total. That one passes. Row total times column total divided by overall total. Yes.
Try to go to the bathroom. Go to the bathroom.
Sure. Don't pee your pants. Or poop them. Okay. let's take a look at our result here. What do you guys notice?
Doesn't pass.
Where am I short? In my first column, correct? So what I'm going to try to do is I think I'm going to try to move a few of these from the green into the yellow. So I'm going to go and take a look at where my divisions are, and if I can sneak a couple more data points from my yellow division into my green division. So I'm going to go back to my data. I'm going to resort this by the X variable. And take a look. Looks like I can slide 4 more greenies into the yellows by deciding to go from 61 to 67. Is everybody okay? So let's try doing that. So I'm going to make these guys yellows. So this is going to be to 67, and this guy becomes to 66. Now when I did that, I get 1 more here, and I get 1 less there. I'm going to get 1, 2, 3 more here, and I'm going to lose 3 from over here. And now I'm going to take a look. Still, how's my total? Still at 50, right? So I must have done my adjustment correctly. You can always like recount from the scratch. If you are like adding some here and subtracting some here, I don't get it. Just recount from the scratch is fine. Did I pass the large counts condition now? No. I got this 4.8 here. Dang it! What am I going to try to do? I'm probably going to try to see if I can sneak a couple of the ones from the blue column into the greens. So if I look at that, oh, look, there's just 171. How convenient is that? I'm just going to flip that to green. So I lost 1 from here and add 1 to here. I guess this is now considered 72, and this is now to 71. But if I do that, what do you notice now? Now I've passed, right? Everybody agree? Yes. All right. Rock and roll. We're on our way. Yeah. I know, it's exciting. All right. Next thing I'm going to compute, now that I have my observed and my expected counts, is I'm going to calculate my chi-squared statistic. Anthony, how do I calculate the chi-squared statistic? The formula, man. You just said it a minute ago. That's why I called on you.
Oh yeah. Observed.
Yes. All right. So I've made a little cell that I called chi-squared calculated. So that's where I'm going to, next to that is where I'm going to type this formula. Now there's a big boy here because there's a lot to do because it's the sum of those values, right? So I'm going to do equals parenthesis observed minus expected, and then shift 6 to get the exponent, and then a 2 divided by expected. And I'm going to do plus and just keep on going. So observed minus expected squared divided by expected. And I'm going to do this 9 times because I have 9 of these things to do, right? Oops. Is everybody okay with what I'm doing right now? Notice that I'm not doing this by hand. I'm building a formula so that my calculator, or so that the computer can do this on its own. That way I can go back and check if things don't look right or if I'm getting kind of like crazy answers. My last one now. There's my chi-squared calculated value. Okay. What else are we going to need? Going to need our degrees of freedom. How do I calculate that? There's no fancy way to do that, so I'll just... Oh, yes, go ahead. Yes. Sure. Okay, and then we need a p-value, right? To get that, I'm going to type into my calculator y equals... and I want chi-squared inverse right tail. Oh, no, I don't. I don't want the chi-squared inverse. I just want chi-squared distribution right tail. So I have my chi-squared calculated, and then my degree of freedom. So there's my p-value. What can we conclude here? We all took a test on this. You can't forget, man. Okay, Emerson. Anthony says to ask you. There's my p-value. What can I conclude? It's less than 0.05, which would be alpha. Well, that's true. What are we accepting or rejecting, though? Like,
We're rejecting the null.
okay.
Accepting the all.
Yes. Yeah. Of course. Okay. Everybody's okay here? On what we've done so far? We'll be talking. Okay. What else are we going to need for our IA? We're going to want to calculate some correlation, build a scatter plot, maybe make a line of best fit. Sound good? Okay. So to calculate R, what do I need? What other statistics do I need? Okay. That's true. What other statistics do I need to calculate R? You guys just did this.
The A, the slope.
Oh, the y-axis.
You need the mean for what?
Oh, you need your mean y and mean x to find your line of best fit.
What else do you, we're not doing the line of best fit right now. I'm asking about R, but we do need X mean and Y mean. What else do we need?
Probably
Y half.
squares.
Huh? No, we're calculating R. Standard deviation. Thank you, Nicole. For X and our standard deviation for Y, right? Let's actually write it this way. Everybody's okay with that? Okay. So to figure out my standard deviation of X, or my mean for X, I'm going to just go next to it. I'm going to type equals. And then what is the mean the same as? The average. So I'm going to type average, double click to fill it, and then it says, I just need to highlight the cells, and then press enter. We'll do the same thing for the Y, average, highlight my cells, enter. There's my average for my mean, or for my Y's. You ready to do standard deviation? So I'll do STD, and then which one do I want? Population or sample? No, man, in this class it's always population.
I did not say.
So again, I'm just going to pick my statistic, highlight my stuff. Isn't this lovely? Now I'll do it for the Y's. Okay. Everybody good with how I did that? All right. So now, if you remember, in your last test, how did we calculate the R value by hand? We used 3 rows or 3 columns in a table, right? What were those 3 columns? I don't know, man. When it gets over. All right. Here we go. Right? So I just kind of typed in what we did. Same thing that's in the tables. So equals, parenthesis, X value, minus X mean, divided by, thanks Alex, X standard deviation. What just happened? What did it do? Why did it do that? It's not what I wanted it to do. Oh, okay. Divided by X standard deviation. Oh my God. All right. There we go. All right. Let's try this again. It didn't. Press something wrong. Okay. Now, I'd like to drag this and drop this, right? So that I can just like repeat the same calculation over and over and over again. Here's the hitch. I don't want the location for the mean and location for the standard deviation to change when I drag and drop it. I just want that X value to change. So what I'm going to do is I'm going to go up to my formula, and the red is where my mean is. You see how the mean box is red and that F21 up there is red? I'm going to type a $sign in front of the letter and a $sign in front of the number. That's going to lock that cell, so when I drag, that cell doesn't move. I'm going to do the same thing for F23. And then I'm going to press enter. I'm now going to drag this all the way down so that it covers all of my cells, right? You see how it's the same depth as all of my cells? Don't drag it past them. And we'll do the same thing now for the y's. So equals y minus y mean divided by y standard deviation. But remember, we don't want the mean and standard deviation to move when we drag. So let's add in some dollar signs to lock those cell locations. And then we'll drag. And then this is just going to be this cell times this cell. So there's my product. Let's say n is 50, right? That's how many data points we have. R then is going to equal the sum of this column divided by the number of things. So there's my R value. Everybody's okay? Let's also calculate our A and our B now for our best fit line. How do I calculate the A? The slope. Right, we have a formula for this. Standard deviation y divided by standard deviation x times the R value, I believe. And then how about the B, the y-intercept? I think that's the y-mean minus the A times the x-mean. Is everybody okay with how I did that? Okay. So I have my observed, my expected counts. I have my R calculations done. What I want to do last here, the last piece of information I probably want is a scatter plot of my data. I'm going to have Excel generate that scatter plot for me. So to do that, I'm going to highlight my 2 columns of data, including the cell titles. So I highlighted the height and shoe size also. And I'm going to pick Insert. And over here, I want the charts. I'm going to pick the bottom option, which is the scatter plot. I'm going to pick this first scatter plot option. And now I'm going to have to do some renaming here because Excel was pretty dumb about this, but that's okay. So if I click on the little plus sign here, I want to add some titles for my axes. And I want to include a trend line. Everybody so far so good? I'm going to make a title for my table. So shoe size is a terrible title. This I'm going to call height versus shoe size because those are my X and Y variables. My X-axis title is going to be height in inches. My Y-axis title is going to be shoe size, and I'll say men's because I think that's what this was. Oops. So far, so good. Now, how do you like the look of this scatter plot? I hate it too. What's wrong with it? It's all like jumbled up in this one stupid spot because the axes are all garbo, right? So what I'm going to do is I'm going to click on these axes and notice on this formatting axis option on the side, it allows me to change these. So for the x-axis, maybe instead of starting at 0, let's start at 60. Boy, that looks a heck of a lot better, right?
Heck yeah.
Woo! All right. Now if I go to the y's, we can do even better, right? Like instead of starting at 0, what do you think we should start at? 6 sounds good to me too. There we go. Now we're cooking with gas. And if I click on my trend line, over here it has display the equation on the table. That's really clever, and I can just grab that and move that. So now I can check it against what I got numerically by the equation. How's my equation match to the A and the B that I found earlier? It's dead on accurate, right? Yes. In addition, on the trend line, there's another option that says display R squared value on the chart. So there's my R squared value, and I bet you if I take this number and I square it, I get that dead on also. Let's do that real quick. Boom! Goes the dynamite. What do you think? Dead on accurate, right? Everybody happy with what I've done? I'll point out to you one other additional thing. Notice when I click on the trend line, there's options for other types of trend lines that you can choose to make. If you read your IA descriptor, there's an opportunity to earn some extra credit on your IA by exploring other fits and deciding like which fit is actually the best for your data. This is how you would do it on Excel. So you're just picking these different ones and like this is changing and it's giving you a new equation and a new R value automatically, right? You need a linear one, but after that, if you want to do the extra credit, it's fairly easy to generate the trend lines and the equations and the R squared values. You have to talk about it then in your paper, but Nicole?
We just pick one that has like how do we know which one?
Well, you want the R squared value that's the biggest.
Okay.
So R squareds are between 0 and 1 because it's literally just R value squared.
Yeah, okay.
But that's your correlation or coefficient of determination for non-linears.
Okay.
So again, you can look at those options, right, and decide. Does everybody feel okay here? Okay. Again, sure. When it comes time for you to do this with your own data, fire up this video, pause, follow along. Hopefully it's relatively easy. The recording I think will be good because I did it at my computer, so I think the sound will capture good for you. In addition, you'll see my mouse moving. Where my mouse cursor is, it's highlighted when I do it, so it should be easy to follow as well. All right, next thing. When it comes time for you to write your IA, you're going to want to be able to type equations into your paper so that they fit nicely. Let's show you how to do this. Okay? When you do this, you need to use Microsoft Office. Google Docs stink at this. They do not work well. The embedding doesn't work well. LaTeX doesn't play nice with Google Docs. It's bad news all around. Okay? So what I'm going to do is I'm just going to open up a Word file and we're going to write out or show you guys how to type in some of these equations by hand, right? So let's say I want to show the equation excuse me guys. Let's say I want to show the formula for the mean and then my work for doing that calculation. Sound good? Okay. So I'm going to start by pressing the Insert tab at the top. And on the far left is the equation editor option. I'm going to click on that. That opens the equation editor. So all of these buttons down here warehouse the different things that you can make your equation look like. So this box in here has a bunch of different options. Probably we're going to live in the basic math option. Over here has fraction options. You probably just want to use a horizontal fraction. Superscript, subscript, both. Options for radicals. We don't do any integration in here. Summations, though, we're going to, right? So those are the summation symbols. If I want to do parentheses or any special kind of brackets, if I need absolute value or whatever. If I need a trig operator, you won't need that. If you need an accent, which we do need, right? Because what's our symbol for mean? I'd probably use X bar, right? So I'm going to choose this option right here that has the little bar over top of it. And I'll type X into it. Notice that how the X is still kind of gray. Let me zoom in a little bit. So right now, anything else I type is going to be have the bar over it. I don't want that. I'm just going to press the right arrow key on my keyboard. Now the X is no longer gray, so anything I type after it won't have the bar over top of it. Everybody's good? Okay. So the formula for mean is 1 over n times, and I don't really need a time symbol, the sum from I equals 1 to n of xi. So if I want a subscript on this, I can pick the script and the subscript option. And there's my formula for mean. Everybody's okay with that? Now, Microsoft Word is going to be picky about this. Notice that if I try to type something in the same line as this formula, it kind of wrecks the formatting for it, right? So you want to just let that thing be on its own line, no spaces, no typing. Just let that all be on one line so it stays pretty and nice and centered. Everybody cool? Now let's show you how I would type in my calculation for mean. So I'm going to do insert, equation, and I'm going to pick accent. I'm going to pick the bar. Say x bar equals. I'm going to press the right arrow so the x is no longer highlighted. Type my equals. And I'm going to do the fraction command. And the denominator of my fraction is 50, right? Because I had 50 data points. And, oops, that's not the one I wanted. If I look at my data points, my first couple of x's were 61, 62, 63. And my last couple were like 76, 76, 76. So I'm going to type 61 plus 62 plus 63 plus ... Notice how the ... automatically formatted into like an ellipsis, and so it's like centered in the middle. Plus 76 plus 76 plus 76. I'm going to press the right arrow till I'm on the right next to my fraction bar. And then I'll write approximately, and I'll go grab my x mean, which was 68.9. Is that enough decimal places? Yeah, how many should it have? 3 sig figs. Now I can just type around it, you know, like blah, 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 stuff, 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 you know, my mean, yada, 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 right? Like, I'm going to write my paper in this and just have like my equations around it. Like I calculated my mean. Like here's the work below. This means that da, 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 da. Everybody's okay? Yes, if it's time to go, you can go. Banders and others. Oops. All right. Now, shh. So like these things from Excel that I created, like my scatter plot, I can just right click on that and copy, and I can like drop it into my paper, and it's going to look exactly the same way. And if I have to do any little like moving around, I can like move around stuff in the paper. So it looks real nice. Is everybody cool with that? See you later. Thanks, you too. Good luck tonight. You're welcome. What do you guys think? Bye. It was a lot, right? Okay. So my suggestion for you guys is you can type the general formulas in right now. You could start doing that right now into a Word document and just like have those at the, you know, like page break those to the end and just like I'll use those when I get there. Type in those general equations right now if you have, you know, 20 or 30 spare minutes, so it's not like a big time suck later on. Right? Once you have your data, if you are I collected my own data, I would try to do this as soon as I can, the Excel sheet. Because once you have that, again, now you can start typing in the work for your separate calculation. And again, you don't have to type around it. You can just, I have a few minutes, 10, 15 minutes here or there. Let me get one more of these calculations into my Word file so that it becomes not sitting down and being like, oh my God, this is like never ending, and keying these things in, which again, it takes some time. I tried to AI my way around it and see if I could find a good way for like the AI to do it for me, to like just give me the thing I could cut and paste in there. It doesn't do a good job with it. I tried for like a solid 30 minutes to see if I could come up with like a phrasing that it would do a good job on this for you. It does not. I know, it's a bummer. But I tried. Everybody feel okay with what we did today? I know this was a lot. It's okay if you have questions later. If you have stuff that's not working, that's okay. I want to say, as fair warning, one of your IA assignments is going to be emailing me your Excel sheet so that I can check it to make sure your calculations are correct, so I don't have to check them again come when it's time to turn in your paper. This is your final. The IA is your final for this course. Okay? What's up? Unless you need to. So what I do is you press the Insert tab, and then you pick the Equation button. And that opens up the equation editor, and you can pick whatever it is you kind of need. Sometimes you just have to click around and see what you're looking for. And you have to be a little bit careful about how you nest things underneath, right? But should be okay. Sound okay? All right. The last thing I will say is when you are typing your paper, typing, and you talk about doing like a chi-squared test or calculating a correlation coefficient or whatever, a mean, you should use the mathematical symbol. So that means going into Equation Editor and pulling like the Greek letter chi, where are you? There. For chi-squared, not using an x. Again, if you have a spare couple of free minutes, make the last page of your Word document and just have like chi and r and like all the little math symbols that you might need just at the end that you can just like highlight, copy and paste, highlight, copy and paste. So you don't have to like go through the equation editor every single time to do that, especially if it's going to be something you're going to talk about a lot. So like if I want chi squared or whatever, I might leave that as like the last page of my Word doc while I'm writing, so I can just go back and highlight and copy and paste them in. So I don't have to do it over and over and over and over again, right? So when you're writing, so like we showed our calculation for how we got the mean. Notice I didn't show every number in there. Don't show every number. Just use an ellipsis. Am I going to bother writing out a similar calculation for the y? No, man, just report your y value and say you did it similarly, right? Same thing if a standard deviation. Just show it for one variable and say you did it the same way to get to the other answer. You do not need to show all of your work. You need to show one sample calculation, and that is sufficient. When you're showing your expected counts, don't show the calculation of every expected count. Quote the general formula, show one example, and then give the table of your expected counts, right? Like, don't make it unnecessarily like equation filled, right? Assume that the person reading this is at a similar mathematical level that you are. And if you give them the formula and you have the raw, the inputs, you can show them one time how to use it and they'll be like, I can figure it out from here. Okay? What do you guys think? It's okay? All right. You want me to stop talking here? I feel like I'm losing my voice here a little bit. It was a lot of me really trying to project today because I want to be really clear about what we're doing and how to do stuff. But I think I got everything in that Excel file that you need to do. If we forget something, we can always circle back and take another day at it. But we're running out of days here before we need to start doing this. Ideally, I'd like you guys, before we leave for Thanksgiving, to have everything you need to start writing. Because there's not a lot. I think there's like 2.5 weeks after we get back from Thanksgiving and then exams start. Okay? So not a lot of writing time. That's why we're doing the introduction now, why I'm going through and showing you the data now, so that if you are able to get a jump on this and get started, you can get started. If you have 50 or plus responses to your survey, you're going to have to look at your individual responses, make sure they're not a bunch like, oh, I have like 7 gobbledygook that I can't use, so I don't really have 50 good responses, right? Like if you ask, how many hours did you sleep last night? And somebody reports cat or something, like, well, that's an insane answer. You don't have to keep that data. Or they said they slept 36 hours. It's like, well, that's impossible, right? Like, you got to make sure that you have real looking data at least. And I will continue. I prompted 2 of my senior mostly classes today to like incentivize them to fill out surveys. I'll do that again on the B day next week to fill out surveys. So if you don't have enough now, hopefully by Tuesday when I see you again, your survey will be mostly filled in, or at least to where you have like 50, 60, 70 responses. Everybody sound okay?
So you should have at least 50.
Well, you saw how narrowly I made the expected counts past the large counts condition with 50. That is by like the skinnier teeth that I was able to get that to work. And that's with made up data that I knew what I could get to make it work. So the more you have, the easier it is to like be able to arrange these things in a sensible way and not have to be like, oh, I have like 1 to 2, and then 2 to 56, and then 56 plus is my categories, which is kind of stupid. But sometimes that is what it is, kind of, you know what I mean? But the more data you have, the more flexibility you have in terms of making that arrangement to get the expected counts to work. So more is better. You know, there's 45-ish of you guys between the two sections. And then I have another probably 50 or 60 students, or well, probably 50 or 60 seniors that are not also in this class. So there should be, you know, if I get a good percentage of everybody responding, we can get you to 70 or 80. Unless you're like Emerson, who's already has a broken survey. When people have, it works now?
Yeah, I did it.
Oh, okay. So it doesn't even, I don't even need to update or hyperlink that. Perfect. There's 2 other people on my list who have broken surveys.
I think this batch.
Yep, and Maggie is the other one.
Wait, no, hers works now.
But Maggie's works now?
I just did it.
Okay, when it this morning it was edit, like it was just had it editable.
Let me check. Oh yeah, if it Ellen Kisman's is like that too. You have to like go where it says publish.
Yeah,
and
she has-
copy the link, and you if you
Oh, I see.
re-put it into a new tab, it
I
works.
responded.
So I can update her then, right?
Yeah,
Okay.
you should be.
All right,
But
let's
I just did that, and I just.
let's look at that. You guys can help me. This thing is fine. Let's just do that. And actually, I'm gonna stop this recording.